Today we're going to continue our exploration of factoring, and we're going to start by looking at a special situation and see if you can find a pattern or a structure that we could use every time this comes up. So we're going to start by talking about perfect squares. Perfect squares are things that when you multiply it times itself. So we're going to just fill out our perfect squares table. So 1 squared is 1. 2 squared, 2 times 2 is 4. Go ahead and pause your video and finish filling out all the perfect squares, and then check back so we can continue. So we've been asked to factor questions 1 through 6, and they're all polynomials. If you start looking at them, take a moment and just see if you can figure out what all 6 of these have in common. So pause your video for a minute and see if you can figure out what kind of structure all 6 of these have, and then start your video back up. Okay, well, each one of these are a perfect square minus another perfect square. Got a perfect square here. I'm subtracting another perfect square. We call this pattern the difference of 2 squares. So a perfect square minus a perfect square. So we're going to go ahead and just start by factoring number 1. So if I think about this, it's really s squared plus 0s minus 49. It's just a trinomial. So I'm going to go ahead and put it into my area model. I'm going to put my s squared and my negative 49. Now we know this negative 49 is a perfect square, or the 49 is a perfect square, and we know that we're going for a 0. So positive 7 and negative 7, when you combine them, will give us our 0. So our answer to this is s plus 7 and s minus 7. Okay, so kind of pay attention to that structure, and let's go do number 2. Again, we have a perfect square minus another perfect square. So when we put them in, we got t squared minus 81. Since we're trying to get to a 0, because we don't have a middle term, we know that plus 9 and minus 9 will become 0, and that gives us our pattern. So our answer to this one is t plus 9, t minus 9. Okay, so maybe you're starting to see the pattern already. Let's do one more. Let's do number 3 and see if our pattern, whatever you've come up with, see if the pattern holds true. Okay, so I've got a perfect square minus a perfect square. So I'm going to put my 16 here, my x squared here. Okay, so square root of 16, that would be 4 times 4. My x squared, to get to a 0 in the middle, it's going to be x and negative x. So my answer is 4 plus x and 4 minus x. Okay, so hopefully you are starting to see the pattern that we're taking the square root of our first term and the square root of our second term, and we're having 1 plus and 1 minus. And it just follows that pattern every time because that's the structure. That is how perfect squares work. So now I want you to do number 4, 5, and 6 on your own. You can use the area models, you can use the pattern and the structure, however you need to do it to get your answers. Pause your video while you do them, and then check back to verify your answers. All right, just check and make sure you got the right answers. So as you can see, you can follow your area model Even if you don't notice that it is a difference of 2 squares, very quickly in your area model work you'll see what the answer is. Or if you just see it right off, then you can go ahead and just follow the pattern. All right, so number 7 and 8, they're wanting us to factor and then solve the equation because we have to get it into factored form before we can solve the equation. So I want you to pause your video to do number 7 and 8, get them all the way worked out down to your solutions, and then check back to check your answers. So the only factoring I could do on either one of these was to take out the greatest common factor, and then it was in factored form, so I set each factor equal to 0 and solve to get all my answers.